welcome to high-level concurrency features in Dart language. My name is Remy and I will be joined later in the video by Angus. What is Dart? Dart is a client-optimized language developed by Google and it's most known for Flutter, a UI toolkit. The high-level concurrency features we're going to talk about are isolates and
Isolates are independent workers that do not share memory with each other. All Dart code is run in an isolate. The only way for isolates to communicate with each other is through message passing. Messages are sent through a send port and are received in a receive port. To create a new isolate, the spawn method is used. Entry point will be a function that takes one argument, in this case, value. A receive port can create many send ports that allow messages to be passed to it. A send port is often passed in as an initial argument when creating a new isolate, or sent back to the creator of an isolate to allow for two-way communication. Listen allows a callback function to be provided that will be called whenever a new message is sent. Messages can be sent through a send port by calling the send method. The type of the message is not specified, and it is up to the receiver to check this type.
To the code example, which is the barber shop. The barber shop is going to have customers, a barber, and a shop, which processes the messages sent between the actors in the actor model, which Dart uses for its isolates. Let's remember the constraints here. We're going to say that there's a maximum of 2 customers in the store at any one time, and the barber needs to sleep when the barber doesn't have hair to cut. These first few classes are what we use for message passing. Let's ignore them for now and jump straight into the main. In the main function, we use isolate.spawn to spawn the callback of a shop. This is going to be our main isolate that processes all the messages. And first of all, we're going to declare a receive port and then isolate.spawn a barber. And we're passing in of this receives port send port. Down in the barber, we're going to get that send port and we're going to send back the barber's own receive port. And once we await it here, essentially we have a way for the barber to now communicate with the shop and the shop to communicate with the barber. This is a very common pattern using isolates. Let's move on. In the shop, we're going to record the number of customers and the max number of customers. And essentially we're just going to sit in a loop here, listening for messages coming to the shop. If the message is a haircut request, we're going to do one set of actions. If the message is a haircut finished, we're going to process the customer leaving. The shop then spawns A, B, C, D for different customers. And let's take a look at what the barber does. So we just went through this. Essentially, the barber's going to sit in a loop, just waiting for messages in its own queue. And if they're a haircut request, the barber's going to cut hair and then send a message to the customer that the haircut's finished. It can do this because our message is of type haircut request, and a haircut request has a send port, which is essentially the address of the customer who's getting the haircut. That means the barber can immediately just send a message to that customer saying, "You're done, it's time to leave." Now the customer is going to first of all request entering the store and request a haircut at the same time, and it's going to do that through the shop by calling send haircut request. This is this class here. So the shop is going to process this request, a haircut request, as we just mentioned. If there's too many customers in the store, it's going to bulk. If there's capacity, then we're going to forward this message on to the barber and let the barber cut the hair and then contact the customer when they're done. Let's run this code. Okay, so we can see down here we have our first customer, Adam, who requests a haircut, enters the store here because there's capacity. The barber is then listening for these haircut requests and processes the haircut. And Adam gets his haircut and knows it's finished when the barber sends this straight to the customer. And then the customer leaves the store after sending a request to the shop. We can see the bulking condition here where Bill requests a haircut, Claire requests a haircut, Debbie requests a haircut, and because there's now 2 people in the store, when Debbie requests, she bulks. That was a super quick example, so let's try to crystallize some of these ideas with a diagram. The shop isolate is the first one that's spawned, and the shop is going to spawn both the barber and the customer. So when it spawns the customer, it's also going to pass in its address, so the customer knows how to contact the shop at a later point in the code. In the same way, when it spawns the barber, it's also going to pass in its address, so the barber can send a message to that address, which is essentially telling the shop how the shop can communicate with it. So after these 2 messages are sent, both the shop can communicate with the barber and the barber can communicate with the shop. Let's take a look at the successful scenario. The customer uses its stored address of the shop to send a message, which is a haircut request. It's also attaching its own customer send port so that whoever receives this message can then use it to contact the customer. First, it sends it to the shop, and the shop decides whether the store is at capacity. In this case, it's not, so it forwards this request on to the barber. The barber then cuts hair and uses the attached address to send a message, which is a haircut result.success. This is the successful flow, and then the customer leaves the store. In the failed flow, the customer uses the shop send port that it's stored from when the isolate was spawned. It sends the haircut request, and the shop uses this to send a message straight back, which is saying the store's at capacity, go away.
Streams are another concurrency construct in Dart. They allow for the processing of asynchronous data without blocking. By listening to a stream, you provide a callback that will be called each time new data is available. There are 2 types of streams in Dart: single subscription streams and broadcast streams. Only one subscriber can ever listen to a single subscription stream. Once that subscriber has unsubscribed to the stream will be closed. A single subscription stream will not send any data until there is a subscriber listening. A broadcast stream can have multiple subscribers and will send data regardless of whether there are subscribers or not. Receive ports used within isolates are a subclass of stream and behave in much the same way. Some of the benefits of isolates include encapsulation, composability, and scalability, which are key attributes of the actor model. Mutual exclusion is also gained for free since there is no sharing of memory. There is also support for checking the types of messages, which reduces bugs. However, isolates also have some confusing syntax, including receive port and send port. They also share some of the weaknesses of the actor model, including complex message passing and no guarantee for how long it will take for a message to be processed by another isolate. Isolates are still susceptible to deadlock and starvation as well.
Critical evaluation of Dart's concurrency features. We thought that it brought intuitive abstractions to solve high-level concurrency problems. It was able to successfully replace lower-level concurrency constructs. And we think it brings much-needed flexibility for concurrency problems in front-end development, most notably the actor model and its support. However, I think it's important that we remember the context of the language. Dart is not a concurrency-first language, and if we evaluate it through the eyes of that, it's going to fall short. It lacks the extensive concurrency library that Java or Kotlin has, and it lacks the features, the scalability, the fault tolerance of a concurrency-first language like Elixir.